Okay, so in this slide presentation, we'll go over some of the basic ideas behind hypothesis testing. So, hypothesis tests are another tool in which we use to evaluate, uh, certain statements about our population, right? So, again, the basic idea is based on our sample, right? What can we say about the population? So, the general idea behind hypothesis testing is the following, right? We want to perform probability calculations to distinguish what we see in our data, right? So what we see, can we distinguish between what we see due to chance and due to the fact that it is what we are seeing is indeed really reflecting a real feature of the phenomenon under study, right? So when we see something in our sample, is it really reflective of the truth or is that just due to random noise? So let's go over. So usually the first thing we do in hypothesis testing is to state our null and alternative hypothesis, right? So we'll just kind of go over an example here. So let's say you're in charge of quality control in your food company. You randomly sample 40 packs of cherry tomatoes, right? And they're supposed to weigh half a pound or 227 grams. But in your sample of 40 packs, you find that the average weight is 226.5 grams. Now, obviously, you cannot expect boxes filled with whole tomatoes to all weigh exactly half a pound, right? Thus, is the weight in a sample of 226.5 grams just due to chance, right? Due to some variation in our cherry tomatoes, it's right. The average, the weight is probably going to be a little bit different from 227 grams. Is this weight in our sample evidence that the machine that sorts the tomatoes need revision, right? So maybe this value is too far away from 227 that it cannot be explained by random sampling. So that's what we want to do. So hypothesis testing uses sample data to decide on the validity of a hypothesis, right? So hypothesis is an assumption or theory about the characteristics of your population. So what we want to know in this question, right, does the calibrating machine that sorts the tomatoes need revision? Now, how can we reframe this question statistically is in terms of population parameters, right? So we could say, is the population mean for the distribution of weights different from 227 grams? Right, so that's the way we could state it, right? So hypothesis statements are about population parameters, right? So population mean, population proportion, so on and so forth. So the statement being tested in a hypothesis test or test of significance is called the null hypothesis and denoted by H naught. The test of significance is designed to assess the strength of the evidence that your sample provides against the null hypothesis. Typically, the null hypothesis is usually a statement of no effect or no difference. I sometimes also like to call it the statement of equality because the null hypothesis is going to say that it's an equal statement. Right? So the alternative hypothesis is a statement we suspect is true instead of the null. Right? So in this example, we'll say the null hypothesis saying that the average weight is equal to 227 grams, and the alternative hypothesis we are saying that the average weight is different from 227 grams. Right, so that's why I call this a statement of equality, and this is different from 227 grams. So there are actually a few different ways to write the alternative hypothesis. So what we saw in the previous example, right, is called a two-sided test because we're saying that the alternative is saying that the average is mean, the population mean is different from a specific number. Now in this example, right, the specific number is 227. Right? Now, depending on your situation, you might be interested in a what we call a one-sided hypothesis test. So your alternative hypothesis could also say your average is different from this value, so or that the average is greater than a specific value. So these tests are if you are interested in testing in one specific direction, whereas a two-sided test is just saying whether it's different from, it could be greater than or less than. Notice in all three examples, the null hypothesis is always the same, right? So really what you're deciding is, based on your question of interest, which of these three are you interested in, right? So in this example, because we're considering whether the machine is faulty, right? So when we say the machine is faulty, it means that the average is different from what it's supposed to be. What determines the choice of your alternative hypothesis is what you know about the problem before you perform a test of statistical significance, right? So it should be driven by your question of interest. So let's say your question that we're looking at is a little bit different. So let's say, right, again, you have it's kind of the same group, same information, but now let's say a consumer advocacy group is trying to claim that consumers are being cheated by the food company. What should the null and alternative hypothesis be in this scenario? So if that is what you're trying to prove, right, the null and alternative hypothesis, well, the alternative hypothesis you have to reconsider. And I'm going to say that in this situation, your alternative hypothesis is now saying that the average is less than 227, right? Because if you think the consumers are being cheated, you're trying to show that they are getting less than what is being advertised. The null is still the same, right? So typically I always focus on writing the alternative first because that's driven by what I want to show. And the null hypothesis is basically the statement of equality. Okay, so this is just how we think about writing the null and alternative hypothesis. Alternative hypothesis is always driven by what you want to show, and the null can always be viewed as the statement of equality. So in the next part of this slide, right, we'll talk about how we then actually evaluate the strength of the evidence against the null hypothesis.